In this video, we are going to talk about integration by trigonometric substitution. Before we start the problems for integration by trigonometric substitution, we have to look at three formulas. One is integral sine 1 over square root 1 minus x square dx is equal to sine inverse x. What you have to remember is if there is an integral involving a square root term such that inside the square root you have a constant first minus x square or variable square, then this is related with sine. Another formula is if you have integral sine 1 over x square root x square minus 1 dx, this is equal to secant inverse x. What you have to remember is if an integral sign involves a square root term such that inside the square root you have the variable square first and then the constant. Unlike the previous case where you had the constant first minus variable square, that is related with sine, but here in this case you have the square root and inside the square root you have the variable square first and then the constant, then this is related with secant. Now look at the third formula. If you have 1 over 1 plus x square dx integral, this is equal to tan inverse x. Now remember that if the integral does not involve any square root and there is something like a constant plus variable square, then this is related with tan. Now let's start with the problems where we have to solve the integral by using the trigonometric substitution. Let's say we have to solve a question. The integral is x square minus 16 divided by x dx. There is no any known formula that would help us to solve this integral directly, so we will solve this question by using the trigonometric substitution. First of all, we have to see that this integral in the question is similar to which three situations on the right hand side. So this question integral involves the square root, fine, so this eliminates this third option because the third option does not involve the square root. So this integral has some similarity either with the first situation or the second situation. Now we can see that this integral is similar to the second situation because it involves the square root and inside the square root the variable square is written first. So this is similar to the second situation. It does not matter that in the actual formula on the right hand side the square root term is in denominator, but here in the question the square root term is in numerator. You just have to see the similarity. Is there inside the square root variable square first or the constant first? If the constant is first, then this would have been similar to the sine inverse situation, but now it's the variable square first, so it is similar to the secant situation. So I will think that this is the secant trigonometric substitution problem. So what you will have to do is first rewrite your integral x whole square minus, and 16 could be written as 4 whole square divided by x dx. Now that we have decided that this is a secant trigonometric substitution problem, so we will make the substitution. What you have to do is look at this term. Inside the square you have the variable x, so you will write x, the inside term, is equal to, now look at this term 4 whole square. So inside the square there is 4, so you will write 4, and since this is the secant substitution question, so I will write secant theta. We know that we have seen the similarity with the second formula which involves secant inverse x, But here you just have to see the similarity, either it's secant or sine or tan, and then you have to make the substitution. In the substitution you don't put the inverse. So it's under the square it was x, so you have taken that. Under the square it was 4, you have taken that, and then secant theta. Now differential of x, which is dx, 4 as it is, and the differential of secant theta, first its derivative secant theta tan theta, and then the differential of theta, which is d theta. If this substitution x is equal to 4 secant theta is correct, then when you will plug the value of x and dx back in this integral, you will see that this square root is eliminated. If this substitution is not correct, the square root will not be eliminated. You will see. Let's put the value of x and dx back in the integral. So we have, in the place of x, we have 4 secant theta whole square minus 16, which is the square of 4, divided by x value, which is 4 secant theta. Dx value is 4 secant theta tan theta d theta. Let's simplify. 4 secant theta cancels out with this 4 secant theta. Inside the square root you have 16 secant square theta minus 1. Outside the square root you have tan theta d theta. Now we know an identity, 1 plus tan square theta is equal to secant square theta. It means that tan square theta could be written as secant square theta minus 1. Let's take 16 out because it's common in these two terms, and since 16 is inside the square root, when it's out it becomes 4. Inside the square root we have secant square theta minus 1 into tan theta d theta. Now this identity on the right hand side, secant square theta minus 1 is equal to tan square theta. We will put this inside the square root. So tan square theta into tan theta d theta. Now this square cancels with this square root. So we have tan theta into tan theta d theta. And then we have 4 tan square theta. There is no direct formula to solve the integral of tan square theta, but again on the right hand side we can use this identity to put the value of tan square theta, which is equal to secant square theta minus 1. So we have tan square theta is equal to secant square theta minus 1 d theta. We will separate it. 4 secant square theta d theta minus 4 outside 1 into d theta. We have this formula, secant square theta d theta integral is equal to tan theta minus 4, and we know that d theta is just theta, 4 theta, plus some constant. But remember that theta was not originally the part of our question, so we'll go back up and see x was taken as 4 sine theta. So x was taken as 4 sine theta. From here we will extract the value of theta. First we will write x by 4 is equal to sine theta, and then theta is equal to sine inverse x by 4. So here we will put the value 4 tan theta is equal to sine inverse x by 4 minus 4 sine inverse x by 4 plus some constant. So here we have solved this integral square root x square minus 16 divided by x dx with respect to trigonometric substitution. Let's solve another problem. We have to integrate 1 over x square root 4 minus x square dx by trigonometric substitution. First of all, we will try to see the similarity of this question with the three formulas that we had written previously on the right hand side. Now please see this. In this question, the square root term is involved. So it means that this is similar to the first two situations. Let's look at the three formulas. So on the right hand side, you can see the three formulas. We have to see the similarity for given question with these three situations. So our actual question involves square root, and inside the square root the constant, which is 4, is written first. So let's look at the similarity again. Our question involves square root, so it means it's not the third situation, because third situation is without the square root. So our question is similar either to the sine situation or the secant situation. Now our question involves the square root, and inside the square root constant, which is 4, is written first. So the first situation involves the square root, and inside the square root the constant is written first. So our question is similar to sine situation. We will go back to our question. We will rewrite it as x square. Inside the square root, 4 could be written as 2 square minus x whole square. Now we know that this is a sine similar situation, so we will make the substitution here. Inside the square root you have x, so you will put x equal to, in this term inside the square you have 2, so you will put 2, and this was a sine similar situation, so I will put sine theta. Remember that here we will not put sine inverse theta, we will simply put sine theta. Differential dx, 2 sine theta derivative is cos theta d theta. Let's put the value of x and dx in our integral. Dx is 2 cos theta d theta divided by, the value of x is 2 sine theta, 2 sine theta square, 2 sine theta square. Inside the square root you have 4 minus the value of x square, 2 sine theta square, gives you 2 cos theta d theta divided by 4 sine square theta. Inside the square root you have 4 minus 4 sine square theta. Let's make some simplification. 2 cancels out with this 2 here. In numerator you have cos theta d theta. In the denominator you have sine square theta. Inside the square root you have 4 common, take it out, it becomes 2, 1 minus sine square theta. You know this identity, sine square theta plus cos square theta is equal to 1. So from here you can take out the value of cos square theta, which is equal to 1 minus sine square theta. Cos theta d theta divided by 4 sine square theta. 1 minus sine square theta is cos square theta. We can see that this square cancels out with this square root. If your substitution is correct, square root will be eliminated. Cos theta divided by 4 sine square theta cos theta. We can see that this cos theta cancels out with this cos theta. We take 4 out, and we also know that 1 over sine theta is equal to cosecant theta. So here 1 over sine square theta could be written as cosecant square theta d theta. We know by formula cosecant square theta d theta integral is equal to minus cot theta plus some constant. So minus 1 over 4 cot theta plus some constant. And remember that theta was not originally the part of our question. We had introduced this in substitution. X is equal to 2 sine theta. So we will write x is equal to 2 sine theta and extract the value of theta, which is equal to x by 2 sine theta, and theta is equal to sine inverse x by 2. Let's plug in the value of theta here. Minus 1 over 4 cot and the value of theta, which is sine inverse x by 2 plus some constant. So this is how we have used trigonometric substitution to find the answer of this integral. Let's attempt one more question. By trigonometric substitution, we have to solve the integral square root x square minus 25 divided by x dx. We will have to see that this integral has similarity with one of the three formulas given on the right hand side. Let's look at the question again. Our given question involves the square root, and inside the square root you have the variable square first. Let's look at the three formulas. So since our question involves square root, so it is definitely not similar to the third situation, which is tan inverse x. So either it is similar to the first formula sine inverse x or the second formula secant inverse x. Now our question involves square root, and inside the square root there is a variable square first. Now we can see that it's similar to the second formula because inside the square root you can see that variable square is written first. So it's a secant similar situation. We'll go back to our question. We will rewrite it, which is x square minus 25 can be written as 5 square divided by x dx. Since it's a secant similar situation, so here we have inside the square x, we will put here equal to, inside the square is 5, we'll put 5, and then secant theta. Let's calculate the differential, which is dx 5 secant theta tan theta d theta. If this substitution is correct, here this square root will be eliminated. We will see that. Let's put the value of x and dx back in our integral. It gives us the value of x is 5 secant theta, so 25 secant square theta, because here it was x square, minus 25 divided by the value of x 5 secant theta, the value of dx 5 secant theta tan theta d theta. 5 secant theta cancels with this 5 secant theta. Inside the square root you have 25 common, take it out of the square root, it becomes 5. Inside the square root you have secant square theta minus 1. Outside the square root you have tan theta d theta. You know this identity, 1 plus tan square theta is equal to secant square theta. So tan square theta is equal to secant square theta minus 1. So by this identity secant square theta minus 1 we have as tan square theta square root into tan theta d theta. Now this square cancels with this square root, so we have 5 tan square theta d theta. By the same identity on the right hand side, tan square theta could be written as secant square theta minus 1, because there is no direct formula to solve this integral tan square theta d theta. So we will have to use the identity. Let's separate it out. It's 5 secant square theta minus 5 d theta. By the formula, secant square theta integral is equal to tan theta minus 5 theta plus some constant. Since theta was not originally the part of our question, but we used it in substitution, x is equal to 5 secant theta. So we will write x is equal to 5 secant theta, and from here we will extract the value of theta. We have x by 5 equal to secant theta, and then theta is equal to secant inverse x by 5. Let's put here 5 tan, the value of theta is secant inverse x by 5 minus 5, the value of theta, which is secant inverse x by 5 plus some constant. And we have solved this integral by trigonometric substitution. In the next video, we are going to talk about how to solve integrals by using partial fractions.